Bismillahirrahmanirrahim. Today we will cover our chapter 4, that is tires or TYRE of automotive technology course. First, the brief description. What is tire? Generally, when you see a tire, you see different types of marking or engraving on the side shoulder of the tires. Let's be familiarized with these numbers or these alphabets. If you see this type of marking on your tires, this depicts the size of your tire or the types of the tire, which kind of tire you are using. Now, this first letter, which is written here as 205, this is your tire width, which is in millimeters. Then we have this tire profile, the aspect ratio, that is 55. We will talk later what is the aspect ratio here. Then this sign, alphabet R or B. There are two types of tire, generally radial and bias, and this is a radial tire with R is the symbol. Then you have different, you maybe have 15, 16, 17 here. Basically, this is the rim size of your tire. This numerics shows the diameter of your rim or the wheel. Then this numeric value, the 91 or 92 or 93, whatsoever it is the load rating. And then this alphabet tells you the speed rating and the speed up till which your tire to be driven is safe. Beyond that, then that speed, it is dangerous. Now let's go in further detail. In some tires, we have this P letter, or generally it is not written there. So basically it stands for the passenger car tire. Generally it is not there now. Then we have this number 215. This is the width of a tire in millimeters. The width which is in contact with the ground or the surface of a tire, that is the width. Then this number is the ratio of height to width. This ratio of this height and then this width. R denotes the radial, B denotes the bias. Then this, the rim diameter from this point to this point is your rim diameter. Then comes the load index. This number tells you the load index, and H alphabets tell you the speed rating. And if your tires having these two alphabets or some other alphabets, M plus S, then it can be used in severe snow condition. US Department of Transportation tire identification mark is written there, identification number. Then we have tire ply composition and material used. It is when written here. Then and further information regarding the tread wear, traction and temperature grades are written on the tires. The maximum load rating it can withstand, and maximum permissible inflation pressure, how much the air pressure or air you can inject in this tire. It is all these informations are there on the tire. So the basic function, before I said basic function, I have already uploaded a video regarding the tire, how you can classify these information and what are the further knowledge you can gain from that video clip. So the basic function of a tire, there are three basic functions of a tire. It supports the vertical load while cushioning against road shocks. So it supports the vertical load while cushioning against road shocks. It develops longitudinal forces for acceleration and braking. It develops longitudinal forces for acceleration and braking. Third is it develops lateral forces for cornering. Cornering is basically while you are turning. So these are the three basic functions of a tire. This chapter, the tires, we will cover from two books. First is your reference, main reference book, that is the book by James D. Alderman. And second portion, we will cover from the principle of vehicle dynamics, that is from Gillespie. So the parts of tire. First is the tread. It's not thread, it's tread. Tread refers to the part of the tire that contacts the ground. So from this portion to this portion, which is in contact with the ground, that portion is known as tread. Tread refers to the part of the tires that connects the ground. Tread rubber is chemically different from other rubber parts of a tire. So this pattern which is you are saying which is in contact with the surface or the ground, its rubber is chemically different from the rubber which you are using for the construction of a tire. Tread rubber is chemically different from other rubber parts of a tire and is compounded for a combination of traction and tire wears. Tread depth is usually 11 by 32 inch deep on a new tires. This depth we are talking about, these grooves, this depth is usually 11 by 13 inch deep on a new tire. Then we have these wear bars as shown by the arrows and in the circles. Wear indicators, also called wear bars, when tread depth is down to the legal limits of 2 by 32 inches, the bald stripes appears across the tread. So this is chapter 109 of your book. Wear indicators, wear bars are stripes of bald treads that shows when the tread depth is down to 2 by 32 inches, the legal limit in many states. So tread is the main part which is in contact with the ground, and its rubber composition is different from the other composition of the rubber which is used in the tire. Then we have a tread depth and wear bar legal limits. Parts of the tire or the further explanation of the tread. The tire tread runs around the circumference of the tire. Circumference of the tire. This light blue or sky blue portion, and its pattern helps maintain traction. This pattern helps maintain the traction. Now this portion which is along the shoulder, this is known as ribs, and these side grooves are known as sipes, and this upper complete portion is tread, and these depth portion are called grooves. The ribs provides grips, while the grooves directs any water on the road away from the surface. The sipes helps the tire grips the road. So every pattern, every design, or every part or portion has its own specific function in a tread. Further explanation, let's start from the lower portion. These steel wires are beads, and around this we have a bead chamfer. Then this, where I'm moving my cursor, this is the radial plies we will study. Then above the radial plies, we have these steel belts. Then we have a cap plies. And above that, we have this thread and side portion that is called shoulder. Then the side grooves, these are sipes. These grooves along the tire is called grooves. This is thread block, this is the rib, and this complete is your thread area. Now, the second part, the sidewall. The sidewall is that part of the tire between the tread and the wheel. From here, the shoulder, where the shoulder starts, till this wheel rim, this is the side wall. The side wall is that part of the tire between the tread and the wheel. The side wall contains all the size and construction details of the tire as we have seen in those figure. So the side walls contains all the size and construction details of a tire. Some tires turns brown on the side walls after a short period of time. Some tires turns brown on the side walls after a short time. This is due to the ozone atmosphere damage that actually caused the rubber to oxidize. So some oxidization is happening on the side rubber, and this caused it to turn brown. Premium quality tires contains an oxidizing chemical additive blended with the sidewall rubber to prevent this discoloration. So to prevent this brownish effect or the color of a sidewall, we use anti-oxidizing chemical additive blended with the sidewall rubber to prevent this discoloration. So this is the sidewall. Now then the bead. Now we are talking about this portion, the bead and bead chamfer. The bead is the foundation of the tire and is located where the tire grips the inside of the wheel rim. The bead is the foundation of the tire and is located where the tire grips the inside of the wheel rim. The bead is constructed of many tons of copper or bronze coated steel wire. So the bead, this bead, it is consists of many tons of copper or bronze coated steel wire. The main body plies layer of materials are wrapped around the bead. So these radial piles, these are wrapped around this beads. The main body plies layer of the materials are wrapped around the bead. Most radial ply tires and all truck tires wrap the beads with additional material to add strength. So we add some additional material here to give further strength to this portion. Caution: if the bead of a tire is cut or damaged, the tire must be replaced immediately. Remember this thing. If the bead of a tire is cut or damaged, the tire must be replaced immediately. Now, typical construction of a radial tire. Some tires have only one body ply and some tires uses more than two belt plies. So this is your bead, coated steel beads along the chamfer. Then these are the radial plies. One layer, then second layer. So this is typical two ply belts. And then we have these belts, and then we have this thread portion. So radial caracas or body plies, which is moving from one bead to the other bead radial. Body ply. Tire gets its strength from the layers of material wrap around both beads under the tread and sidewall rubber. So basically this rubber Now we are talking about this body ply. A tire gets its strength from the layers of material wrap around both beads under the tread and sidewall rubber. This creates a main framework or carcass of the tire. These body plies are often called carcass plies. A 4-ply tire has 4 separate layers of materials, means one complete layer, then we have an other layer, then 2-ply, another layer, 3-ply, and other layer, 4-ply. So then the tire will be having a 4-ply rating. Okay. If the body plies overlap at an angle bias, the tire is called a bias ply tire. If the body ply is having an angle with each other, then the plies type is a bias ply tire. If only one or two body plies are used and they do not cross at an angle but lie directly from bead to bead, then the tire is called radial. If it is lie do not cross an angle, then it is a radial. But if there is some angle over during the overlapping, then that tire is a bias tire. Simple is like this. Belt. A tire belt is two or more layer of material applied over the body plies. So body plies is moving from one bead to another bead. If they are radially with no angle, then it is a radial. If there is some angle between them, then it is a bias tire. Now, this belt, a tire belt is two or more layer of material applied over the body plies. So above that body ply, we have a other layer of material that is a belt, and under the tread area only. This material is only under the tread area. Okay. To stabilize, belt is to stabilize the tread and increase tread life and handling. Belt material can consist of a steel mesh, nylon, rayon, fiberglass, or aramid. So belt in an extra layer of material which is applied under the tread on the plies to maintain, to achieve more stabilized and increase the tread life and handling. So belt material can consist of steel mesh, nylon, rayon, fiber, glass, and aramid. So let's see all these parts, tire parts. First, we have the beads, hexagonal beads we have. Then we have a wrap around the steel clipper. Then we have a bead clipper. Then we have this fabric chamfer, then chamfer pad. Then we have this turn up cover here. Then the shoulder pads, the side walls, the shoulder, the tread, the base component, the protective belt, working belt 2, working belt 1, transition belt, then the body ply, inner liner. So bead, then we have these body plies, then we have transition belt, then one belt, second belt, then we have this tread, these side walls, shoulder, and then we have this chamfer arrangement and the beads. Now tire construction. There are two types of tire as we have seen. There are two types, radial construction and bias construction. And third, not very common, diagonal bias. But we will talk about the radial construction and the bias construction. First is the radial construction. Radial construction is characterized by parallel plies. So these plies, which is coming from one bead and going to the opposite side on the other bead. So radial construction is characterized by parallel plies, rubberized fabric reinforced by a cord of a nylon, rayon, polyester, or fiberglass. running directly across the tire from one bead to the other at a nominal 90-degree angle to the circumference. 90-degree angle to the circumference. These plies are referred to as a caracas, which we know. I read again. Radial construction is characterized by parallel plies. Parallel plies. Okay, this one like this. Rubberized fabric reinforced by cord of a nylon, rayon, polyester, or fiberglass, running directly across the tire from one bead to the other at a nominal 90-degree angle to the circumference. These plies are referred to as the carcass. Carcass. This type of construction makes for an extremely flexible sidewall and a soft ride, but provides little or no directional stability. So when we have this type of ply arrangement, this type of ply arrangement will give you extremely flexible sidewall and soft ride, but provides little or no directional stability. So this is the demerit or disadvantage in this type. So to provide the directional stability, a stiff belt of fabric or steel wire that runs around the circumference of the tire between the carcass and the tread. So above that radial ply, we use stiff belt of fabric or steel wires that turns around the circumference of the tires between the carcass and the tread. So that stiff belt or fabric or steel wire gives us the directional stability in these type of tires. The chord angle is the belts is normally within about 20 degree of the tread. The chord angle, this angle with this angle. The chord angle in the belt is normally within about 20 degree of the tread. In cornering, the belts helps to stabilize the tread, keeping it flat on the road despite lateral deflection of the tire. When we are moving and turning, this belt arrangement helps this to stabilize the tread, keeping it flat on the road despite the lateral deflection of the tire. If we are moving, then here will be more forces as compared to here. Or if we are moving in this direction, more forces will be acting on this as compared to this. Most radial passenger cars tires have a two-ply fabric sidewall and either one or two steel belts or 2 or 6 fabric belts. So this two-ply fabric sidewall, either 1 or 2 steel belts or 2 to 6 fabric belts. So it depends how much ply rating we are getting. Now the second construction type is the bias construction. But let's see the difference between these two. In bias tire construction, the carcass is made up of 2 or more plies extending from bead to bead with the cord at high angle 35 to 40 to the circumference and alternating in the direction from ply. So this is the angle which they are making with each other. This is 35 to 40 to the circumference. Okay. In previous case, those were the parallel lines like this. But here we are having these angles. So in bias tire construction, the carcass is made up of 2 or more plies extending from bead to bead with cords at high angle 35 to 40 to the circumference and alternating in the direction from ply to ply. High angle results in tires which are soft for ride comfort, but low angles are best for directional stability. So High angles results in tires which are soft for ride comfort, but low angles are best for directional stability. So one, if it has a merit, then other is a demerit. Although a bias ply carcass is literally much stiffer than a radial ply tire. Remember this thing? A bias ply carcass is literally much stiffer than a radial ply tire. In cornering, the bias plies allows the tread to roll under, putting more load on the outer rib. So in cornering, while turning, the bias plies allows the tread to roll under, putting more load on the outer ribs. Okay. Bias construction also causes more distortion in the contact patch as the toroid deforms into a flat shape, causing the tread to squim in the contact patch when rolling. Let's see. Now, if your tire is moving in a clockwise direction, then this is your leading edge and this is your trailing edge. We are moving in this direction and tire is rotating in a clockwise direction, like I am moving my cursor. So this is your leading edge. This portion will come in contact with first, and then this is your trailing edge. So squirm in the contact patch of a bias ply. The pattern of a contact patch will be like this. The forces will be acting like this. Now, size and load rating. Tire size is denoted by one of the several methods, variously including the section height, distance from the bead seat to the outer extreme of the thread, section width, maximum width across the shoulder, aspect ratio, ratio of height to width, rim diameter. Let's see. See, this is the section height, section width, aspect ratio, and diameter. Section height is from this portion, from this to this, from bead to this. Section width is from shoulder to shoulder. Aspect ratio is section height, this one, to section width, this one, and rim dia is the diagonal dia. This is your rim diameter. The tire and rim association defines the method of designating tire size and the load range for which they should be designed by the manufacturer. In bias tire size, example like 6.95-14 denotes the section width with the first number. So 6.95 is the section width and 14 is the rim size. These both numbers, the unit is in inches. Bias tire size, example 6.95-14, denotes the section width with the first number and the rim size with the second, both in inches unit. But whereas in radial tires, the radial tire size, example 175R14, denotes the section width in millimeters. So 175 is the section width in millimeters and R is the rim diameter in inches. In bias tire, both the width and the rim size in inches, but in radial tire size, the width section is in millimeters, but the rim diameter is in inches. Now, tire size designation. Let's see, on the left side, we have this original size of a radial tire. We have 205, the section width. Then 75 is the aspect ratio. Okay. And 15 is the rim size. So what is the size of the tire is? So 15 is inches is the diameter of the rim. Then we have 154. The aspect ratio we will find. The aspect ratio is 205 section width divided by the section height. So it will be 154 mm, 154 mm. So we will get 308 mm, 12 inches. So the outside diameter is 12 inches plus 15, so 27 inches. Now, if we say that this is the original size, I want to go with +1 size, then +1 size means we are increasing the rim diameter. Initially, the original was 15, but with +1 size, the rim diameter is 16. But the outer diameter should remain in this range, 27 inches. We cannot go further beyond it. So we have to maintain the outer diameter and we have increased the rim diameter. So the cut will be on the aspect ratio. So the aspect ratio will be reduced here. And with this formula, we have to be in 27-inch outer diameter. So 16-inch plus 135 mm, 135 mm is 270 mm. This comes out to be 10.6 inches. So it is 26.6 inches. Now, if we say I want to go on +2 size, +2 size means plus 2 inches from the 2 inches from the original size. So original was 15. Now the +2 is 17 inches. So the cut will be on the aspect ratio, section width to section height. So this will be reduced from initially it was 154 mm, then it is 135. Now it is 127 mm. So dia is increasing, aspect ratio is decreasing, and width is increasing. 20 increase here, 20 increase here. Okay, but this is theoretical. Okay, in practical, we will see in next slide how much we can go. So 127 mm plus 127 mm, so it comes out to be 10 inches. So 10 inches plus 17, so 27. The outer diameter should remains the same, no matter which size you use, +1, +2, or original. Now, how much bigger can I go? The tire should be the same outside diameter as the original to maintain the proper suspension, steering, and ride height specification. So whatsoever size you are using, original +1, +2, the outside diameter should be as to the original to be maintained, because your suspension system, your steering system, your ride height specification are designed on that dimensions. Tire size affects vehicle speed sensors values. If you are changing the tire size, it will affect your speed sensors value, your anti-lock braking system, brake wheel sensors values that can change automatic transmission operation and ABS operation. The tire should not be so wide as to contact the inner wheel well or suspension component. So you have to keep this in mind, the width. It should not be so that it should touching the gap between the body and the wheel. So it should be, there should be a gap between the wheel and the body. It should not be touching the walls of the body or the suspension system. Generally, a tire that is 10 mm wider is acceptable. Practically speaking, 10 mm wider we can accept. Beyond that, then it will be a difficult task for the turning operation. For example, an original equipment tire size is 205, the width of a tire, 75 is the side aspect ratio into 15 is the rim diameter. So the outside diameter comes out to be 27.1 inches, can be changed to 215 by 75 into 15. The outside diameter is 27.6 inches. This much change is less than half inch in width and increases the outside diameter by half inch. Whenever changing tires, make sure that the load capacity is the same or greater than that of the original tires. Now, if we are going from original to +1 or +2, or we are changing the size of the tire, remember one thing, that the load capacity which is mentioned in the original tire, it should be maintained or it should be greater than that. If wider tires are desired, a lower aspect ratio is required to maintain the same or close to the same overall outside diameter of the tire, as we have seen in this. Now, cross-sectional view of a typical tire showing the terminologies, section width in millimeter. Then we have this aspect ratio. R is the construction type, radial biased belt or diagonal bias. So 15 is the rim diameter in inches, 92 is the load index, and H is the speed rating. And this is your section width. This is your section height. Aspect ratio is the section height divided by section width. This portion is your tread area. This portion is your shoulder area. Then this is your side valve area. Then lower side valve area. This is the tubeless wall. Then rim, we have the bead, radial ply, and then we have a belt packing here. Speed index. Speed index indicates sustained speeds at which the tire is designed. This speed index or speed rating. Tire can still fail at this speed and even below this speed. There are possibilities that tire can still fail at this speed and even below this speed, but it is not designed for continuous operation beyond this speed. So this is the safety limit. Beyond this, we cannot continuously operate the tire. Load index. Load index is the amount of maximum weight that can be safely put on the individual wheels. So load index, it is of that particular tire, not the complete vehicle. It is, if we have to calculate for the complete vehicles, then we have to add all the load index of all the tires. So the load index is the amount of maximum weight that can be safely put on the individual wheels. So the load index is an abbreviated method to indicate the load carrying capability of a tire. The weight listed in the chart represents the weight that each tire can safely support. Let's see the chart. So this is from your book. If the load index says 75, then it can carry 387 kg of load or 853 of pound. If it is say 110 of the load index, then it can carry 1060 kg or 2337 pound. Similarly, so on the different values. 95 means 690 kg or 1521 pounds. Now, the weight listed in the chart represents the weight that each tire can safely sport. So this can sport up to that much of kg. Multiply this amount by 4 to get the maximum that the vehicle should weigh fully loaded with cargo and passenger. So next comes the speed rating. Let's suppose we have this tire and it's written as H. So the speed rating is 130 miles per hour or 210 kilometer per hour. These are the letters from L to Z, and these are the corresponding rated speeds, maximum rated speed. Let's suppose we have a tire with letter S. It can go up to 180 kilometer per hour or 112 mile per hour. If we have a rating of Z, it is open-ended. It can go beyond this. Okay. So these are the speed ratings. What effect does tire size have on overall gear ratio? If we are changing the gear tire size, what it will affect on the gear ratio or speed or the different things on the vehicle. The customer often asks what effect changing tire size has on fuel economy and speedometer readings. If larger or smaller tires are installed on a vehicle, many other factors also will change. This includes the following. Now, if we fiddles with the original size, let's see. Speedometer reading. If larger diameter tires are used, the speedometer will read slower than you are actually traveling. This can result in speed dictating. So remember this thing. If you are using larger tires instead of original tires, your speedometer will show slower, but actually you are traveling fast. So you will get a speeding ticket. Odometer reading. I hope you people know what is speedometer and what is odometer. Speedometer is telling you the speed of the vehicle, how much is the velocity or the speed of the vehicle. Odometer is basically the meter which is telling you how much the distance it has covered. Odometer reading, even though larger tires are said to give better fuel economy, just the opposite can be calculated. Since the larger diameter tires travel farther than the smaller diameter tire, the larger tire will cause the odometer to read a shorter distance than the vehicle actually travels. So this is the catching point here. Even though larger tires are said to give better fuel economy, just the opposite can be calculated. Since the larger diameter tires travel faster than a smaller diameter tire, the larger tire will cause the odometer to read a shorter distance than the vehicle actually travels. For example, if the odometer reads 100 miles travel on a tires that are 10% oversized in circumference, the actual distance traveled is 110 miles. So actually you have covered 110 miles, but your odometer reading will give you that you have only covered 100 miles. So there will be a difference if you are using a larger diameter of a tire. Third point is the fuel economy. If fuel economy is calculated on miles traveled, the result will be the lower fuel economy than for the same vehicle with the original tires. Now let's see some formulas to calculate all these things. First, we have to calculate the tire circumference. The formula is pi multiplied by wheel size in inches. Wheel size in inches means diameter of the rim size. Then we 25.4, we are converting that inches into millimeters. Then we have tire width in millimeters. 205, 255, 275, whatsoever, into tire height ratio as a percentage. Divided by 100, multiply by 2, then we get the tire circumference. Then speed kilometer per hour. We have the engine speed as RPM, the gear ratio in which we are moving, then the final drive ratio in which the power is going to the wheels, multiplied by tire circumference divided by 10, 1 million, multiplied by 60 into speed. So this will give us the speed kilometer per hour. Then converting that speed kilometer per hour, that speed kilometer per hour divided by 1.61 or 1.609. So for the calculation, miles per hour, the RPM of an engine into diameter into 3 pi divided by the gear ratio, or RPM miles per hour into gear ratio divided by diameter into 3 pi into pi. Gear ratio RPM into diameter into pi by miles per hour. So I gave this general numerical to my students. First, the basic data is the tire size. We are given with the width of a tire, that is 225, and the aspect ratio, the 45. R is telling us it's a radial tire, and the rim size or the diameter of the tire is 16. Engine RPM, we gave it as 7,000 maximum. Gear ratios, it's a 6 gear ratios, 6 gears we are having. We are not taking into account the reverse gear. Okay, first gear, the speed ratio is, gear ratio is 3.5, 3.3. In second gear, the ratio is 2.25. Third, we have 1.75. Fourth is direct drive, in which 1:1. Fifth is overdrive, 0.85, and sixth is 0.8, more faster. And the final drive ratio is 4.266. Now we have to calculate following. Speed in each gear with the formula which we have, this one, in kilometers per hour and miles per hour. Then speed in each gear with +1 and +2, practical size, not theoretical. Okay. Then we have to make a comparison table. Now, first we have calculated the tire circumference. It comes out to be this, then the gears and the corresponding speed in miles per hour and the kilometers per hour, and so on with you can do with the +1 and +2. So with this, we comes to the end of our part 1 of chapter 4, the tires. In next chapter, we will study more regarding the tire. Do consult the book and the video which I have uploaded previously for this. Thank you very much for joining me.